Greetings, this is Greg. I want to go over the water injection setup in my Fiat 124. It's a pretty advanced setup and I think it may be of interest to some of my viewers. I took these pictures with my cell phone as I was in a bit of a hurry at the time, but they're good enough for you to see the relevant components. I'll mention that I have nearly no commercial interest in water injection systems, meaning I don't sell them. I do manufacture the intercooler piping seen in this video, so full disclosure, I have a commercial interest there. I also have a certain level of interest in the gauges and the injection controller, as Eurocompulsion is selling those things, and I handle tech support for these products and others, so while this isn't intended to be a commercial YouTube channel, sometimes my hobbies and work overlap a bit, and that's what's happening here. This video will be limited to the description of system components and the control unit, which is pretty special. I'm not going to get into the advantages of different fluids or quantities of fluid to inject, nor do I plan on going into detail on tuning or dyno results in this particular video. If there's much interest in those things, I can cover them in another video, but this one is just about the layouts and basics of these system components. So let's start in the trunk. We have a 3/4 gallon tank, which is fine for street driving, totally inadequate for any serious track action, meaning any track action other than a drag strip. As my car doesn't have a roll bar, that's just fine. I can go about 1 or 2 tanks of gasoline in spirited street driving before it runs low. The tank and most components in the trunk are from Devil's Own, but direct equivalent or even in some cases identical components can be purchased from Cooling Mist, Snow, or others. Normally I run water, but sometimes I'll run water methanol. Optionally, it's possible to run pure methanol, although for that I would, for myself, want braided stainless steel lines for extra safety because methanol is flammable. Of course, we never really run 2,4,5-trioxane. Now I should mention that some people mix in nitromethane with the water and methanol, but that's a little bit outside the scope of what I want to talk about. At the bottom of the tank is an outlet with a built-in filter, and mounted down low on the side of the tank, you can see we have a low-level sensor. The pump is capable of putting out 300 psi. The grounds for the pump and the low-level sensor are behind the trunk liner. The power wire for the pump, the sensor wire, and the fluid line all exit the trunk and run under the car up to the engine bay. If you watch my video on the Oldsmobile Jetfire or the BF109K4, you may wonder why we need a pump at all, since those engines just used boost pressure to move the fluid. The difference here is that for this application we cannot spray in pre-turbo, thus fluid pressure has to be higher than boost pressure or the system won't spray at all. Moving up to the cabin, we have various lights and gauges that are helpful here. The 124's dash is not too friendly for mounting things, so my red level light had to be a bit out of the direct line of sight. However, it's bright, so I notice it when it comes on, and it comes on early enough that I have plenty of warning that the tank is running low. The light is wired to a source of ignition-supplied power, and the switching works by grounding the light. This reduces the amount of wiring needed. Next, we have a green light, which is under the speedometer. This light has some important functions. It's essentially a system on light, but most on lights just mean that the pump is getting power. They don't necessarily mean that the system is actually spraying. That's not too good. There are a lot of scenarios where the pump might get power, but not actually spray. For example, the pump could be damaged, the spray nozzle could be clogged, or there could be a big leak in the system, or the tank could be empty. So, in this case, the green light is wired up in such a way that it gets power whenever ignition is on, but it only grounds when the fluid pressure at the spray nozzle goes above a preset value. This grounding function is controlled by a pressure switch located between the check valve and the spray nozzle, so when pressure reaches the preset value, the light comes on. Thus, the green light in this car truly means that the system is spraying unless it has a clogged nozzle. However, in the event that the nozzle starts to clog, I'll see that because the green light will stay on after the system switches off. So the green light functions as a clogged nozzle detector and as a true system is spraying light. I want to mention that David at Cooling Mist taught me this setup, and I like it a lot. I added 2 gauges, a boost gauge and a post-intercooler air temperature gauge. I especially like having the temperature gauge as it gives me extra assurance that the system is spraying. Let's move up to the front of the car. This picture should help you get oriented. Zooming in, we can see the check valve. Alternatively, you could use a solenoid here, and normally that's what I run on this car, but I was doing some experimenting at the time that I took these pictures. In any case, you need either a check valve or a solenoid to ensure that fluid won't be drawn into the intercooler piping unless you want the system to be spraying. There are pros and cons to both methods, but the short version is that the check valve is easier, but the solenoid is better in terms of ultimate system performance. Zooming back out a bit, after the check valve you can see we have a T-junction which is nickel plated. This is where we take the pressure and send it to the pressure switch in one direction and the spray nozzle in the other. I want to mention that some of the routing and zip ties are not permanent. This car is a test bed for me and I'm always changing stuff. Hence, zip ties work pretty well for my purposes. Next, we have three things. First is the pressure switch used to turn on the green light. It's from Devil's Own and it's an adjustable 5 to 30 psi switch and it's set to 30. Ideally, I should change it out for one that triggers at about 60 psi, but time constraints forced me to use what I had sitting on the shelves. To the right of that, we have the temperature sensor, and forward of that, down low, is the spray nozzle. The sensor and nozzle are both mounted into the silicone tubing. To do this, I used a part specifically made for this job. The part comes from Devil's Own, and it works perfectly, meaning it's secure and it seals airtight even at extreme boost levels. Of course, in order to install it, you have to be able to access the back side of it. That means it's necessary to locate it within about 8 inches of one of the two ends of the intercooler piping, because you have to be able to get a wrench in there. In my case, I located it nearer to the intercooler end of the tube. There are several reasons I did it this way. First of all, this gauge isn't specific to my intercooler kit. Anyone installing this in a 124's factory piping will have to locate the sensor in roughly the same area, because the throttle end of the factory pipe is hard plastic with a short, flexible rubber coupler with no room for a nozzle adapter. Additionally, the car already has a temp sensor in the intake manifold, so I can check to make sure OBD2 readings at that sensor are normal if I really need to. The main reason was that it's just a lot of work to remove the intercooler piping from the car, because the throttle end is very difficult to access on the 124. Using this nozzle location, I didn't have to remove the pipe. I installed it with the pipe still on the car. Of course, there are two drawbacks to this location. First, temperature at this point is about 10 degrees Fahrenheit lower than it is in the intake manifold. That's not really a problem since I'm only looking for a relative increase or decrease, but it's worth noting. Second, because the sensor is so close to the water injection nozzle, I can't see the full effect of evaporation in the intake pipe, although the temperature on the gauge does drop enough so I can see that the water injection system switches on. So that's the whole system except for the controller. In the past on these cars, I had the water injection configured to either be off or above a certain level of boost it would switch on. I was controlling the quantity of spray via nozzle sizing. An on-off system, although very common, is far from ideal because the engine's water needs vary with both boost and RPM. Thus, if it's simply on or off, then when the system is on, it's spraying too much at low RPM and not enough at higher RPM. This not only sacrifices performance, it causes you to go through the fluid at a relatively high rate, since every time you want to pass on the highway, the system goes right into full spray. To address this, I am using the Vaitrix controller. There are quite a few water injection controllers on the market, but I'll argue that this one has the most capability by far, which is the reason I'm using it. In the case of the Fiat 124, we need to be able to control the spray by both boost and by engine RPM. The 124 does not have an airflow sensor, so controllers that rely on signals from such sensors are not an option here. The Vaitrix controller can control pump output based on boost and RPM. It can also control a solenoid by both boost and RPM. In fact, the controller on my car, there are 3 different versions of this product. The one on my car can control 2 pumps and 2 solenoids, although on my 124 I don't have any use for that. 1 pump and 1 solenoid is all I need. However, I suppose at some point in the future I could use the second set to run a nitrous system or something else, but I don't have any plans to do so, and I haven't thought that through fully either. The unit is programmable through computer software. It's also possible to download pre-made maps, of which there are many. The programming is pretty simple. I'll touch on the basics right now. Let's zoom in on the chart. In the open box, we have various selections. Load is used to determine which boost sensor you want to use to operate the system. Most turbo cars have a pressure sensor before and one after the throttle. You can choose which sensor to use by selecting OP1 or OP2. Typically, I use the sensor that's after the throttle. The next numbers set the minimum and maximum pump duty cycle. I always leave those at 10 and 100. On the main chart, we have two parameters to look at: map sensor voltage for the vertical axis and engine RPM for the horizontal. As an example, on the 124, 2.5 volts from this sensor means you have about 8.4 pounds of boost. Of course, cars with map sensors using different ranges will have different boost levels corresponding to any given voltage. So, if we put the number 30 in the cell that corresponds to 2.5 volts and 3000 RPM, the system will run the pump at 30% when the engine reaches 3000 RPM if it's at 8.5 pounds of boost or higher. Naturally, at higher boost levels and at the same RPM, we want more spray. So at 2.8 volts at 3000 RPM, we might want to put in 35. And at 3.8 volts at 6000 RPM, we might put in 100 in order to have full spray. That 3.8 volts would be about 20 pounds of boost. That would be quite a bit on this motor at 6000 RPM. Of course, full spray means the maximum limit of the nozzle. So if you have a 10 gallon per hour nozzle, that would be 10 gallons per hour. You might think that by running the pump at 30%, that would mean that you would spray 3 gallons per hour, but it will actually be a little bit less. That's a complex issue I may discuss in another video. So that's the basics of how the system works. It's really easy to increase or decrease spray at any point in the RPM or boost range to fine-tune this system. The control for the solenoid is equally simple, although, as I said, at the moment my car has a simple check valve on it. But the solenoid itself is simple to operate. It's actually more simple than the boost duty cycle because the solenoid is either open or closed. The number 1 equals open, 0 equals closed. There are some other safety features like voltage compensation so that a drop in system voltage due to something like an alternator failure or something else going wrong will not cause the spray to decrease. Now, for the main functionality, the system can vary boost throughout a tremendous range, so you can take advantage of that spray by increasing boost. This is actually the primary function of this device. I suspect most people that buy it don't even run water injection. That's a feature of the device. I think this is the most effective piggyback tuning module on the market. It's the most effective one I know of, and I've used quite a few. Tuning the boost levels is done in the same way as water injection, except that the numbers you enter into the cells have different values. If you want to change peak boost at 3500 from 14 psi to say 19 psi, you increase the number in the cell. 0 in one of those cells equals no change. So if you just wanted to run water injection, you would have these cells all zeroed out and then configure the water injection tables as we discussed earlier. Now, since this is a video on water injection, I don't want to get too much into changing boost levels yet, but just be aware that that's a big part of what this device can do, because part of the reason you're going to want to spray water is so that you can turn the boost up, and this does both. I hope that explains how I have the water injection configured in my 124 and why I configured it the way I did. Before I go, I want to mention just a few more things. In the description below, I will link a video that does a pretty good job of explaining more of the capabilities of the Vaitrix box. It's from the Vaitrix operator in Australia. It's quite a good video. I'll also link a couple of airplane videos that I have that relate to water methanol injection if you're curious about the history of those systems. I also want to mention that the Vaitrix box I was describing here and showing software images for relate to the mid-range and top-range Vaitrix piggyback box. There are actually 3 units. The basic one is called, well, the basic, and it has essentially all the same capability in terms of tuning the engine, changing boost and so forth. But the Booster Basic can only run water injection in 2 stages, as opposed to this total control that's on the mid-range and top-end box, as I showed here. The big difference with the top-end box is that it can control more stuff. 2 pumps, 2 solenoids, and it can generate, it can take more inputs and outputs from sensors on the engines and things. For the purposes of a 4-cylinder car like the Fiat 124, the mid-range box would offer all you could possibly use. And in fact, the basic box has more capability than any other piggyback I know of for this type of car, and at a very competitive price. Anyhow, thanks for watching, and I hope everybody has a great day.